आउज़ुबिल्लाहिमिनश्शैतानिर्रजीम बिस्मिल्लाहिर्रहमानिर्रहीम रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़्दतम मिन लिसानी यफ़क़हू क़ौली रब्बि ज़िदनी इल्मा। Assalamu alaikum students, welcome to EPSEC's online support program, and this is the lecture for first year physics. The contents of today's lecture will be a topic that is selected from chapter number 8 waves from page number 259 to 264, and the topic is speed of sound in gases. The students' learning outcomes will be to calculate the speed of sound in gases, the numerical formula, the derivation according to Newton's formula as well as according to Laplace correction. Speed of sound. Definition. The distance covered by sound wave per unit time is called speed of sound. It depends upon elasticity of the medium and density of the medium. Now, what is the meaning of elasticity? It is basically the modulus of elasticity from the formula of Hooke's law, that stress is directly proportional to strain, and whenever there is a constant, it is known as the modulus of elasticity. One important thing is that elasticity is inversely proportional to compressibility. What is compressibility? Compressibility is the ability of a material to change its shape, to deform its shape. Means the object which is more compressible, it has least modulus of elasticity. On the other hand, the object which is least compressible, it has more modulus of elasticity. So what will be the conclusion? That the elasticity and compressibility, they are inversely proportional to each other. A medium's elastic property determine whether or not medium will deform or lose its shape due to external forces. Sound travels faster in mediums with high elasticity and minimal deformity. Means a sound can travel faster in solids than in liquids, and the least speed of sound will be in gases. Sound travel more slowly in mediums with great density. First formula will be the Newton's formula of speed of sound. Formula tracked by Newton and expressed as V is equals to under root E upon rho, where E is the modulus of elasticity and rho is the density of the medium. So we are considering only gases here. So the formula formation which Newton has taken is according to the isothermal process. Now, what is the isothermal process? The definition of isothermal process is, it is the process in which the temperature of a system remains constant. The heat transfer of heat into or out of the system happens so slowly that thermal equilibrium is maintained. Okay, now you can see in the graph form, it is the initial situation, the initial parameters, where this closed container has initial pressure P1 and volume V1 at temperature constant. So iso means same and thermal means temperature. So it is basically the process that takes place at constant temperature. So if we are taking constant the temperature variable, then we can plot a graph between the other two variables, that are pressure and volume. So you can see here, this is the initial pressure and the initial volume, it is V1. After increasing the pressure or decreasing the pressure, if I am decreasing the pressure, means on the inverse proportion there is increase in volume. So you can see this is the initial pressure and volume, and this is the final pressure and volume at the constant temperature. Now what is the variation? Initial volume is decreased as well as the initial pressure is maximum, whereas the final volume is maximum but the pressure will be low. So you can see this graph form. This graph form is known as isotherm. So the last form is written as Ht is equals to constant, P1 V1 is equals to P2 V2. So we can apply Boyle's law here. According to Newton, when sound waves propagate in air, compression and rarefactions are formed. Because sound waves are compressional waves, they behave in medium like a longitudinal wave, so they form compressions and rarefactions. Now again I have to revise what are longitudinal waves. Longitudinal waves are those waves in which the production of wave and the direction of motion of wave are parallel to each other. So if sound waves are longitudinal waves, then Newton assumed that the process of uh, forming the compressions and rarefactions in air is very slow, and the heat produced during these formation and the heat lost during the rarefactions is gained from the surroundings. So the temperature remains constant, means the temperature will become same throughout the compressions and rarefactions. So the temperature remain constant and the sound wave propagate through an isothermal process. So according to this behavior, according to this uh, variation, Newton has derived its relation for speed of sound. Now derivation of Newton's formula. According to Boyle's law, PV is equals to constant, because we can see a relation between pressure and volume when temperature is constant. So as you have seen in the previous slides, that the pressure is changed from P plus delta P, so the volume will be changed from V minus delta V. If I am increasing the pressure for the compressions, then the volume will be decreased. Then applying Boyle's law, you have to put this equation in the first form, PV is equals to constant, then this will become PV is equals to P plus delta P into V minus delta V. So next thing will be multiplying these factors, so P into V, then P minus delta V, then delta P into V minus delta V delta P. Now as you have seen that this delta V is very smaller for factor, so we can ignore this factor, it is very small change, whereas PV and PV they cancel out. We are left with only two terms, that is P delta V is equal to V delta P. Now you have to take this delta V from this side of equality to the other side, and it is now the factor as V delta P upon delta V. Now I can also write it like this V under this delta V. How can I write it? It will become a factor known as stress and volumetric strain, where delta P is the stress because pressure is equals to force per unit area, and this is stress, and delta V upon V means the change in volume per unit volume. So the change in volume per unit volume is represented as volumetric strain. So remember that stress has unit of Newton per meter square, but strain has no unit, it is just a ratio. So stress on strain is represented as the modulus of elasticity. So if this factor, the right hand side of this equation number 1 is equal to E, so we can write P is equals to E, means instead of writing the modulus of elasticity, we have to write pressure in that initial equation. So the equation becomes V is equals to under root P upon rho. Now how the calculation begins. According to the pressure in fluids, the formula is rho GH. So as you can see that this rho is the density of mercury, where G is the gravity, but it is in centimeter per second square, and H is the height of that barometer for calculating the pressure, atmospheric pressure, and rho is the density of air. So by putting these all constants, the value will become 280 meter per second, but This is the theoretical value and it is 16% less than the experimental value, so there is some flaw in the formula of Newton, which is corrected by Laplace, and we will see it in the next slide. So according to Laplace correction, he has assumed that the process of compression and rarefaction occur very fast and no exchange of heat takes place, thus the temperature does not remain constant and the propagation of sound in gas is an adiabatic process. So according to Laplace, the process of compression and rarefaction is very fast, whereas according to Newton, the process is very slow of forming the compression and rarefaction. So according to Laplace, the heat cannot be transferred because the process is very fast. So if there is no exchange of heat, then the process is adiabatic process. Now we have to see what is adiabat. Now according to adiabatic process is a type of thermodynamic process which occurs without transferring heat or mass between the system and its surrounding, in which no heat is given to the system as well as no heat taken away from the system. For this behavior, we have to see the thermally insulated walls around that cylinder. This is the state 1, in which this gas has maximum pressure but low volume. On the other hand, this gas has low pressure but maximum volume, but the walls are insulated, so no heat can be take place outside or within the system, but there is a change in temperature within the system. Okay, so you can see this adiabat over here. It's a graph between pressure and volume, so you can see it's a curve, and this curve is known as adiabatic curve. But how can we calculate this curve? By the factor of PV into gamma is equals to constant, because the temperature is also varying, as you can see by the variables, that P1 P2 for pressure change, V1 V2 for volume change, and T1 T2 for temperature change. So we cannot apply the Boyle's law in its original position, that is PV is equals to constant, because for applying Boyle's law the third parameter temperature must be constant. But as you can see, in the process of adiabatic expansion there is no temperature constant between compression and rarefaction, so we have to apply a constant known as the specific heat constant on volume. So after understanding this process, we have to use the modified form as PV gamma is equals to constant. So again the pressure will be changed from P plus delta P, and V volume will change from V minus delta V. So again, by applying this, we can put the values in equation number 2 by P plus delta P into V minus delta V into gamma. So it's PV gamma, and what I have done in the second equation, in the second figure, I have taken out V gamma common, so I can make the internal expression as 1 minus delta V upon V. If something is not common between the two expressions, then when we are taking common, then what will happen? This will divide over here, so delta V upon V. Now as you can see that V gamma and V gamma are cancelling from both sides, but how to solve this expression of 1 minus delta V upon V into whole gamma? How can we solve it? And this is the binomial theorem, and we have to neglect the higher terms. So this is the basic formation of binomial theorem. It is 1 plus minus x power n. So how can we open it up to the orders? It is the first order that this power will be multiplied with this variable, so it is 1 plus minus n into x up to higher power. So we have to neglect the squaring powers and the higher powers, so we have to solve it for till first order only. So if I have to solve this 1 minus delta V upon V over here, then I can write it 1 minus delta V upon V into gamma. Okay, so this will be the final expression for this equation number 3 after applying the binomial theorem. that this power of gamma is now multiplying with the variable delta v upon v. So the next step will be just multiplication, and then we will move towards the final equation. So again I have to multiply the factors, so it's p then plus delta p minus p will multiply with this whole factor, it will gamma p delta v upon v minus gamma delta p delta v upon v. Next, as you can see that this delta p is equals to p delta gamma p delta v upon v, as p and p are cancelling from both sides, as well as this delta v delta p factor is very smaller, so we have to neglect it. We are left with gamma p is equals to delta p upon delta v upon v. As you have already understand in the previous formula of Newton that this whole factor is equal to capital E because of stress upon volumetric strain, so we can apply this E instead of this whole factor, and now this E is equals to gamma p. So we have to put this factor instead of E upon rho, we have to write gamma p upon rho, and this is the final formula of Laplace correction. So how can we solve it? So V is equals to under root rho gamma gh upon rho, where this rho is the density of mercury and the downward rho is the density of air in which that sound is traveling in that medium. Now for this rho, as I have already told you that this gamma is the specific heat constant, so it has a constant value of 1.2. So by multiplying all these values we are left with 333 meter per second, and this is the accurate value of speed of sound according to Laplace correction. This is all for today. If you have any queries you can ask me. Thank you so much. Allah Hafiz.